Hello, and welcome to Iron Beetle, a Twitch and YouTube show where we study this new database called TigerBeetle, which is a weird one. It is not an SQL database, but it isn't like, no SQL database either, because actually it provides full ACID transaction support. And it doesn't give you like typical object document model or key value model, which you might see in a typical NoSQL database. And rather, what TigerBeetle does is it solves only one super specific problem, and that is accounting, tracking the movement of value between accounts. That's all that TigerBeetle does. So usually we take a part of TigerBeetle and dissect it. Like we try to understand like really what it does, why it does that way, how it is written in Zeek without allocation, how do we test it. And last time we finished our big arc about adaptive replication routing. So today I was promising to you that we are going to look into queries. And actually, I think I did promise that we will look into queries exactly at the time where we started adaptive replication routing. So you see where it is going. We are not going to look into queries today because an exciting thing happened. A new fuzzer just dropped. So we are going to review this new TigerBeetle fuzzer and actually write some code to improve it. But before that, I realized that I actually might want to show a proof of work of sorts that we are not playing toys here. So remember we did like a bunch of refactors while reviewing adaptive replication routing. Well, I think, yeah. We actually did learn this work earlier today. So thanks for you for helping me to make this change. Okay, so let's officially start today's episode. Okay, I realize that I probably need to do this. I mean, it's very sunny day here in Portugal, but I've heard that most of you prefer duck theme on your screen, so I will oblige. Okay, so new fuzzer. fuzzer, which fuzzes the message bus. I think we've covered MessageBus 3 times already. Well, let me revisit to do that. We don't have MessageBus here. Okay, we don't have MessageBus here. Then my recollection should be correct. Well, do we have Rodin? Okay, yeah. Well, not Rodin. Okay, never mind. So 3 times, like one, like on like the very first episode of Iron Beetle, while we were starting this whole series. The second time we kind of like reviewed what MessageBus does, and then finally, I think I showed you pool-based MessageBus and message buffer, like how we changed the interface of the MessageBus to not feed messages one by one into a replica, but rather to batch the interface. To say, replica, here is all the messages that I have for you. Okay, so the trouble with MessageBus is that it was, the trouble with MessageBus was that it was the component which gave us most of the troubles. And the reason for that is that it interfaces with the real world, with the real operating system. It does the syscalls. And so it is not part of our deterministic fuzzer. And that means it was historically much less tested than the rest of the system. Now, this is fine, like in that meme with like a dog-looking creature in a burning room, because Tiger Beetle doesn't actually require MessageBus to be correct. There are like super lax requirements, like, hey, like, please, like, don't be Byzantine. So if like some messages are dropped, if messages delivered out of order, if something got lost or got misdirected, it doesn't really matter. It won't definitely compromise correctness, and likely it won't even compromise availability. But still, we want to get MessageBus correct. So that's why or rather DJ, wrote this MessageBus fuzzer. So it is about 1,000 lines of code. So it is not exactly a tiny amount of code, but also it's not particularly complicated. Because if you look at the MessageBus, you'll see, like, it is a thing which manages network connections. So it has like a bunch of actually pretty scary state. But crucially, it is parameterized by this IO type. Hi there. And this IO type is what actually does the syscall. So we have IO send, IO receive, listen, and accept. And that's like, essentially the interface. So the way this fuzzer works is that we have an IO implementation internally, which implements all those methods, which it should implement, and also obviously injects all kinds of errors here to really thoroughly test the thing. So what are we going to do today is we are going to fix this to-do, test, suspend, resume. So what is suspend, resume? Let's quickly revisit that thing which I told you about the interface between MessageBus and replica. So if we go to replica, we have this onMessages call. And onMessages is called by the MessageBus if there are incoming messages. And that is like, a guideline. Never think about having only one of an item. Always think in bunches of items. So on messages passes a message buffer which might contain more than one message. And it provides an iteration interface to read messages out of this buffer. And the message bus can consume this message, saying, okay, I'm going to receive it, and then it goes and processes this message. But message bus also can suspend this message. So let's see how suspend message works. So if what we have received is a prepare, and we don't happen to have any journal rights available, we say, okay, I'm going to suspend this message. And this message remains inside this buffer, and it will be fetched again. Wow, when? I think well, obviously I don't think. Let's see, I think there should be, okay, yeah, here it is. Resume receive. So let's see. In suspend message, we say, hey, if we are receiving a block message and we don't have any grid writes available, we are going to suspend this message. But then when we finish a different grid write, like some grid write, and now we have grid writes, we can now notify message bus saying, hey, message bus, actually, at this point, I am ready to receive a new message. Okay, actually, let's see. Let's double check that suspend message and resume receive match. So this condition matches to this receive. Okay, thanks Superblock update finish matches this condition. And write prepare callback matches this condition. So we should have exactly that amount of resume receive calls as there are conditions in here. Okay. And what resume receive does is that it checks that any messages are queued. And if some messages are queued, then it says the flag is saying, okay, I want to resume receiving of messages and queues this resumption. There is this like debouncing thing going on, so that if we call resume receive twice, we are resumed only once. And when we resume, we go through all the connections which were suspended, and we go and resume each one of those suspended connections. So that's why this is kind of like tricky code, which we would like to test, because like maintaining this intrusive linked list, intrusive queue rather, of connections which are suspended is kind of like tricky. So kind of like you see, like, we call on message, and we have, if we still have message left, then we like add this to suspension, and then like crucially, there is also like shutdown path and on shutdown, yeah, and on shutdown, if we also have messages suspended, then we return and we actually wait until all those messages are processed. So we don't do abrupt shutdown. So like anyway, it's kind of like a bunch of logic there. So we should test it. But the good news here, I think, is that testing this shouldn't be much of a problem. Because, oh, like kill to do. So, okay, to do fixed. The hard part is done. Let's see. Okay, so this is probably its own messages callback. So let's do this. Let's so here is but a checksum. Assert that wow, we managed to write, well, okay. Why is it not seeing standard X? It should see. Equal bytes. Okay, I need to pass T there. So I want to say that the original header and message header are the same, and this is VSR header. Okay. Here I should say if okay, can I aha. So I need to say something PRNG chance IO options spend probability and well I need IO. So not type. Do we have IO here already? Okay, we do have IO here. So oh, okay. So this is where we initialize node. So we could say IO IO. And here as well. And so we only do this if we are a replica. Node IO PNG, node IO suspend probability, and here we should say what shall we say? We shall say buffer. What the replica says? Buffer suspend message. Okay. That's good. Actually, let's see. Can we run this as tests? It is MessageBus. Okay, so to run this, we run zik build fuzz MessageBus. What's cooking? We are extending the fuzzer for MessageBus, the component of TigerBittle, which is responsible for taking abstract TigerBittle messaging protocol, which is unordered message passing, and implementing it on top of TCP. And in particular, we are extending MessageBus to feature, to implement suspend, well, not to implement, to test already implemented suspend feature. When a replica can say, hey, MessageBus, I can see that you have a message ready, but please suspend it for a moment. Okay, suspend probability. What are the options? Receive, send, close, shut down. Message suspend probability is also going to be ratio. And it's kind of like, doesn't really belong to IO, but also feels fine. Message suspend probability. So okay, let's make it more generous. Let's say that we can go as high as suspending every second message. And it says we don't have message suspend probability. Why is that? So, well, obviously it means that I've made a typo. Please plans. Probability, yeah. That one feels more correct to me because it is shorter. Hey, it immediately bugged. It immediately bugged because we must continue here. Like, we cannot simultaneously consume and suspend a message. So it's good that we got a very specific error message saying, hey, you are using the iterator wrong. It still failed. Okay. Because we delivered only 14 out of 200 messages, which is reasonable because we suspended everything. So we also should periodically call resume message suspend probability, message resume probability. And that's like not high. Okay, now we want to go and say if, well, actually, we don't. Well, okay, it's still kind of like is inside an options. I don't know. Like, because so this like message suspend probability, message resume probability, that isn't really property of an IO. It is rather property of a node. But it is just too darn convenient to just parameterize node by IO directly so that we can use it. Well, let's see. Do we have any other probabilities somewhere? Node ID, message bus, messages pending. Well, okay. Now let's do this the nice way. Let's keep okay. So actually, I only want to say AO PRNG suspend probability. Hey, actually, this is nice. Should I just vary turnout? Yeah. Okay. Okay. I'm just going to vary this per node because why not? So and okay, you see how kind of like I started with like very vague figure, but hey, actually these probabilities don't really belong to IO, but then it turns out that actually PRG options const options struct ratio. Okay, and now it kind of like becomes more reasonable. Okay, so now, actually, I mean, we don't even have to specialize this to be replica, because we're testing MessageBus, and like, you know, we want to strengthen contract which we guarantee. Any how do we call this? Well, okay, let's. Well, no, okay. I'm turned here. Switch not line else, not any options. So if node options message resume probability, node resume receive send message, and we also have resume receive. Not any MessageBus resume receive. I think that's it. Let's see if the compiler agrees with me. No, obviously it doesn't agree with me. Okay, what's wrong? So this one wants to be PRNG, and actually this one also could be just PRNG. And here, well, okay, it's fine. Yeah. Well, it's obviously PRNG, not IO. Okay, so this one is not a function. Okay, passed. So let's run it one more time. Okay, I feel like we are super super fast here. Well, okay, maybe if we actually compile this code with LLM with optimizations, we will slow down sufficiently. Okay, while that is cooking, let's maybe quickly look through like the outline of a fuzzer, but it's kind of like relatively straightforward. So like there is some setup, we generate like distribution of weights for various messages. We create this randomized IO, then we create a bunch of replicas and a bunch of nodes, and it's kind of like really ugly that we use separate types for the client message bus and the replica message bus, but like whatever. We prepare some messages. We schedule them to be sent. So, oh no. Okay, so this is like pings, and these are like the actual like, normal prepare messages. Okay, and then we like run for a certain number of steps, and on each step we either inject a message in the network, or we like do a ticket and resume receive thing. Okay, so we got our first farce failure, but I bet that this is just due to small number of ticks, I hope. Nope. This is not due to okay, so this now gets curious. Could it be the case that we have found a bug? Oh, okay. I think I found a bug because well, obviously the resume suspend probabilities shouldn't be too low. So this should fix it, I think. Okay. While we are at it, let's actually like, okay. So I kind of like winced a little bit when writing this, you remember? And now we had a bug here, so let's actually dedupe this. What was that seed again? And I think I don't actually, maybe I don't actually need to. So, okay, so it is incorrect. Okay, yeah, because this is range inclusive. Const result. If result ability how do I call this PRNG numerator? Hey. Okay, actually, this should be resume and this should be suspend. So this is the bug. It is different. Can I say okay, let's do this stupid way. Node options. Okay, yeah. So this works. Let's try again to run it for a little while and see if that still works. So yeah, while it's compiling, let's kind of quickly. So we looked at the setup where we generate messages and then we inject messages. And then we look at the I/O, which is relatively straightforward. So we I/O essentially maintains a set of sockets. So where socket is just a number. So each client and each replica in the simulated network opens a bunch of sockets. Each socket gets a unique number, and the set of these numbers is managed by I/O. So it kind of like remembers the sockets which are listener sockets, so which could accept new connections, and the socket which model connections. And important detail here is that this like socket connection is a half of a connection. So for an actual connection between two nodes in the network, we will see two connections in this auto array hash map unmanaged. So then, for example, let's kind of like follow like the flow here. So first, someone says, hey, I'm going to listen to this address. And then we say, okay, so now we have the server. Then it is going to accept and we say, okay, so this is going to accept in the future. In the accept, we see if anyone tried to connect to us, and if they can, we kind of like say, hey, we kind of like connected the two connections together. Like this is triggered by the connect. So if someone tries to connect, we see if we have a server there, and if we have a server there, we go and add this connection to the list of connections on the server, to the backlog. So backlog is just like an array list of connections. So this is the thing which in accept we pull an item from and use. So then send appends to the connection buffer, and then receive similarly pulls from the connection buffer, but obviously we like have all kinds of errors there. Okay, we are done. So I think I want to do one more thing here, which is node any, node type, suspended. So I want to say that we only are going to resume receive if we have a suspended message. Do I want to do this? So what I'm protecting against? I'm protecting against message getting suspended without actually anyone suspended it. So I kind of like, if I don't suspend the message, I don't resume it. Okay, so actually, what I want to say okay, so I definitely want to say node message bus resume receive, but I think I only want to guard this. So not to, if I want to track whether, so kind of like there's like two things I want to check here, which are fighting. One is that I want to make sure that if I never suspend and never resume suspend, I nonetheless don't have to resume. Like I receive error messages. But another thing I want to check is that if I resumed redundantly without suspending, that also worked. Okay, I think actually it works fine. So okay, I think I don't actually need to do anything here. I just want to so let's say that this is also goes all the way up to 10, like, maybe we always resume. But we actually, how would I say it? So I basically don't want this to be 0. Help me. So what okay, so I kind of like I want to resume suspend probability. If it is non-zero, I want to roll. If it is 0, so if it is greater than 0, I want to re-roll this to. Okay, let's see what we had before. No, like before. Okay, yeah, this probably is it. So okay, so now I think we have like both spurious resumptions when suspend probability is 0 and resume probability is greater than 1. But we also have a case where both suspend probability and resume probability are both at zeros. And I cannot assign to a constant, which is easy to fix by not making this a constant. Resume probability. Numerator. Okay, so let's see. Bus suspend resume. And has a separate error node. Suspend probability and periodic resume probability. Notes that neither suspend nor resume are possible. To check that resumption is not necessary unless there was a suspension. And I think can suspend usability is positive. Okay, so I think we could create a branch as suspend resume, push it, and submit a pull request. Hey, how do I, okay, yes. I don't want to compare the changes. I want to actually go and submit a pull request here. Okay, yeah, that's what I expected to see. Okay, and let's Fuzzbus. Okay, so that's it for today, I think. Nice little quick episode where we learned how we learned two things. First, we learned how we fuzz MessageBus, how you could go and simulate your TCP IP stack. And then we learned how you could extend that to Fuzzing message suspension resumption thing. And we get reminded of this powerful principle that you should always be batching, because why suspend? Why resume? Because, you know, when you receive messages from a network, you're never going to receive like just a single message. You are going to receive a bunch of them, and you might actually want to do quality of service and prioritization. So you shouldn't unnecessarily constrain your interface to say, hey, we receive a message at a time. Your interface should really be saying, like, hey, this is everything I've got so far. I could remove some messages from the buffer, but I could also keep some things buffered. Okay, I guess that's a recap. So, I was going to say that next time we'll meet each other again at 5 p.m. UTC live on Twitch on Thursday, October 9th. But I'm afraid that on October 9th, I'm going to be on the top of a Table Mountain in South Africa. So sadly, there won't be an Iron Middle episode next week. But the week after that, or maybe 2 weeks, okay, maybe I will miss 2 episodes, but we'll definitely are going to continue with queries after that. Okay, bye, folks.